From a design perspective, we should be able to calculate how many bits, how many borrowed bits that we might need to add on to the classful mask of a network address in order to give us a certain number of subnets. For example, you're told to use the 172.16.0.0/16 block of private IP addresses for a particular campus in your company at a particular location. You've got different buildings. You don't want to use that one big address space for all of the devices at that entire company location. You probably want to divide that up a little bit. So the big design question becomes, how many subnets do you want? Oh, you want 15? You want 21? You want 32? That determines how many borrowed bits we need. That determines how many bits we need to add on to the classful, to the natural, to the default subnet mask. And here's the formula. The number of subnets that we will create can be calculated with the formula of 2 raised to the power of s, where s is the number of borrowed bits. In other words, this is the number of bits that we go beyond our classful network mask. Let's take a look at an example. Let's say that we've got a network address of 192.168.1.0. Its natural mask is a 24-bit mask. It's a Class C IP address, and therefore it's got 24 bits in its natural or its classful mask. And we know that that can be written as 192.168.1.0 255.255.255.0, or if we prefer prefix notation, it can be written as 192.168.1.0/24. But what if we borrowed 3 bits? What would our subnet mask look like then? Well, let's take a look at that last octet. We're extending the subnet mask into that last octet. It's going to look like this. We're going to have 3 ones. We've got 3 borrowed bits beyond the classful mask, and then we've got 5 zeros. What is 1110000 in binary? What is that in decimal? It's a 224. That means that the subnet mask is going to become 255.255.255.224. And getting back to the main question now, how many subnets did we create when we extended the subnet mask by 3 bits? Let's do the math. 2 raised to the power of 3, in other words, 2 times 2 times 2, that's an 8. We now have 8 available subnets. And you might be wondering, what are those available subnets? What IP addresses can I assign? As a reference, I've got them listed in the table for you on screen, and we've previously seen how to do this calculation in binary. Remember, we set all the host bits to a 0, and that gives us our network address for a subnet. We calculate the subnet mask by having a series of left justified 1s that correspond to the network portion of the address, followed by a series of right justified 0s that correspond to the host portion of the address. That's how we get the subnet mask. And if we want to calculate the directed broadcast IP address, there we set all the host bits to a 1. And that leaves us with a usable range of IP addresses. And I've given you that range here on screen, but in the real world, that's a lot of calculation, and not just in the real world, on the exam. It's time-consuming to do calculations in binary as we just did. I wanted you to see the foundation. I wanted you to get the fundamentals of how this works. I wanted you to understand the why behind all this. But coming up, we're going to see in a future video a shortcut for doing this calculation very, very easily without having to get into a lot of binary math. The big takeaway from this video is we can calculate the number of subnets that we have created by raising 2 to the power of however many borrowed bits that we added on to that subnet mask. Keeping our network architect hats on for a few moments, let's see how to calculate the number of available hosts. In other words, the number of assignable IP addresses that we're going to have within a subnet. Remember, when we're doing subnetting, we're extending the classful or the natural mask by a certain number of bits, and those are called borrowed bits. And those borrowed bits, they now become part of our network bits. The remaining bits, the right justified bits, that are represented as zeros in our subnet mask, those are our host bits. That's the number of bits that determines how many assignable IP addresses are we going to have in the subnet. The formula is the number of assignable IP addresses in a subnet equals 2 to the h minus 2, where h is the number of host bits that we have in the subnet mask. And you might be wondering, why are we subtracting 2? Why not just say 2 to the h, similar to our subnet calculation? Well, remember, if we have all of our host bits set to a 0 in an IP address, by definition, that's the network address. Similarly, if we have all of the host bits set to a 1, by definition, that's the directed broadcast address. And sticking with our previous example of where we had a Class C network, which has 24 bits in the subnet mask by default, and we borrowed 3 bits, we extended that 24-bit mask by 3 additional bits. That gave us a 27-bit subnet mask, meaning that we have 5 remaining host bits, 32 bits total. 32 minus 27 is 5. We've got 5 host bits. How many assignable IP addresses can I have in each of these subnets that we've created? Well, it's going to be 2 to the power of 5 minus 2. Again, we're subtracting 2 because we cannot use the IP address where all the host bits are set to a 0. That's the network address. We cannot use the IP address where all host bits are set to a 1. That's the directed broadcast address. So we have to subtract 2. 2 to the 5th minus 2 is going to be 30. 2 to the 5th is going to be 32, and we subtract 2. That gives us 30 assignable IP addresses.